June 13th, 1944. 4:17 in the morning. The first V-1 flying bomb crossed the English Channel under cover of darkness. Its pulse jet engine roared like a broken motorcycle, a sound that would soon become the heartbeat of terror over southern England. The weapon was crude, brutal, and effective, a pilotless aircraft packed with 1,870 pounds of high explosive, launched from concrete ramps along the French coast. It flew straight and low, its gyroscopic autopilot keeping it on course until the fuel ran out and the engine cut. Then silence. And then obliteration. If you find these stories of courage and strategy inspiring, please take a moment to like this video, subscribe to our channel, and share your thoughts in the comments below. Your support helps us keep these historical legacies alive. The people of London called them buzz bombs or doodle bugs. The official designation was Vergeltungswaffe 1, Vengeance Weapon 1. They came without warning, without mercy, and in the first weeks of the campaign, they came almost without answer. British fighters scrambled to intercept them, but the V-1s flew at 400 miles per hour, fast enough to outrun most propeller aircraft at low altitude. Anti-aircraft guns fired into the sky, but the bombs were small, fast, and unpredictable. Gunners relied on optical sights, human reflexes, and hope. The hit rate was abysmal. By the end of June, over 2,000 V-1s had struck England. Nearly 6,000 civilians were dead. The city that had survived the Blitz, that had endured night after night of German bombardment with stoic resolve, now faced something new, something that required no pilot, no courage, no human decision. It was a weapon of automation, and it seemed almost unstoppable. But in a world at war, unstoppable is simply a challenge waiting for an answer. In the summer of 1944, the German High Command believed they had unleashed a weapon that would break British morale and force the Allies to reconsider their invasion plans. The V-1 was cheap, mass-producible, and required no trained aircrew. Each bomb cost roughly 5,000 Reichsmarks, a fraction of the price of a manned bomber, and could be launched by a small ground crew in minutes. From the German perspective, it was a masterstroke of efficiency. If the British could not stop them, the campaign would drain resources, spread fear, and disrupt the logistics of the war effort. And at first, they were right. The Royal Air Force threw everything it had at the problem. Spitfires and Tempests chased the bombs across the channel, trying to tip their wings or shoot them down before they reached the coast. Some pilots succeeded, flying alongside the V-1s and using their wingtips to destabilize the gyroscope. It was dangerous, exhausting work. Anti-aircraft batteries formed a defensive belt south of London, but their success rate hovered below 10%. The gunners were brave, experienced, and utterly outmatched by the speed and size of the target. The Germans watched the chaos with satisfaction. British intelligence intercepts revealed confusion, frustration, and fear in the Allied command structure. The V-1 campaign was working, but the Germans made one critical miscalculation. They assumed that radar, the technology the British had used so effectively during the Battle of Britain, was limited. They believed it could track large formations of bombers, guide night fighters, and warn of incoming raids. But precision fire control, automated targeting, real-time gun laying based on continuous radar tracking, that, the Germans thought, was science fiction, a bluff. Propaganda to intimidate Luftwaffe pilots. They were catastrophically wrong. In the spring of 1944, a convoy of American trucks rolled through the English countryside, carrying equipment that would change the nature of air defense forever. The crates were unmarked, the destination classified. Inside were units of the SCR 584, a portable microwave radar system developed by the Massachusetts Institute of Technology's Radiation Laboratory. It was not the first radar. Britain's chain-home system had been operational since 1940, but it was something entirely new in capability and precision. The SCR 584 operated at a frequency of 3,000 megahertz, far higher than earlier systems. This allowed it to generate a narrow, focused beam that could track a single object with extraordinary accuracy. It could measure range to within 25 yards. It could detect a target the size of a V-1 flying bomb at a distance of over 30 miles. And most importantly, it could feed real-time data directly into an analog fire control computer that calculated the precise angle, elevation, and timing needed to intercept a moving target. When linked to an M9 gun director and a battery of 90mm anti-aircraft guns, the SCR 584 became something the world had never seen, a fully automated weapons system. The gun crews no longer needed to see the target. They no longer needed to estimate its speed or altitude. They simply loaded the shells and followed the orders of the machine. The Germans had no idea such a system existed. By early July, the first SCR 584 units were deployed along the southern coast of England, integrated into anti-aircraft batteries tasked with stopping the V1 onslaught. The American crews who operated them were young, trained in the sterile laboratories and classrooms of the United States, most of them unfamiliar with the realities of total war. They had been told their equipment was cutting-edge, experimental, even revolutionary, but they had no idea if it would work under fire. On the night of July 6, 1944, they found out. The radar operator sat in the darkened truck, watching the green phosphorescent glow of the cathoscope. A blip appeared at the edge of the screen, small, fast, moving northwest. The system locked on. The tracking antenna swiveled automatically, following the target with mechanical precision. Data flowed into the M9 director: range, altitude, speed, bearing. The computer calculated the firing solution in seconds. Orders were transmitted to the gun crews. Outside, the 90mm guns rotated smoothly on their mounts, elevating to the calculated angle. The crews loaded shells with time delay fuses set by the director. They did not see the target. They did not hear its engine. They simply obeyed the numbers. The order came: fire. 4 guns fired in rapid succession, the muzzle flashes lighting the night. 4 shells arced into the sky, their fuses timed to detonate at the precise moment and location where the radar predicted the target would be. 3 seconds later, the V1 exploded in midair, a bright orange fireball against the black sky. Debris rained into the channel. The crew stood in stunned silence. Then someone shouted. Then everyone shouted. It had worked. Over the next 2 weeks, the success rate of the SCR 584 batteries climbed from 10% to over 70%. By the end of July, some batteries were achieving 90% interception rates. The V1s that had terrorized London for weeks were being systematically annihilated before they reached the coast. The skies over England, which had been filled with the droning roar of pulse jets and the thunder of explosions, grew quieter. German intelligence reports noted the change with alarm. Something had shifted. The British anti-aircraft fire had become unnaturally accurate. Bombs that should have reached their targets were exploding miles offshore or disintegrating over open fields. The loss rate was unsustainable. At first, the Germans attributed the improvement to better training, or perhaps the use of proximity fuses, a technology they knew the Allies possessed. But proximity fuses detonated near the target, not at a precise calculated point in space. The pattern of interceptions suggested something else, something predictive, something automated. Captured German officers, interrogated after the war, admitted they had not believed such technology was possible in 1944. They had known about radar. Their own Würzburg systems were competent, if less precise. But the idea of radar-directed automatic fire control seemed beyond the current state of the art. They had assumed the British and Americans were years away from such capability. They were wrong by decades. The SCR 584 was not magic. It was mathematics, physics, and engineering, combined with the industrial capacity to produce thousands of units and deploy them across multiple theaters of war. But to the German soldiers who launched the V1s, and to the Luftwaffe officers who analyzed the failure of the campaign, it might as well have been sorcery. They had expected the Allies to fight with courage, with superior numbers, perhaps with better logistics. They had not expected them to fight with precision, with systems that could see in the dark, calculate trajectories faster than any human, and destroy targets without hesitation or error. The SCR 584 was a symbol of something the Axis powers had underestimated: the Allied capacity for innovation under pressure. While Germany poured resources into wonder weapons, rockets, jets, super-heavy tanks, the Allies focused on systems that multiplied the effectiveness of ordinary soldiers. Radar, proximity fuses, electronic computers, logistics networks. These were not glamorous, they did not inspire propaganda posters, but they won wars. The V1 campaign continued through the summer and into the autumn of 1944, but its effectiveness had been broken. Of the roughly 10,000 V1s launched at England, fewer than 2,500 reached their targets. The rest were destroyed by fighters, barrage balloons, or, most commonly, by radar-directed anti-aircraft fire. The SCR 584 had turned the tide. There is a photograph, taken in August of 1944, of an American radar crew standing beside their SCR 584 unit somewhere on the coast of Kent. They are young men, most of them not yet 25. They wear helmets and fatigues, and their faces are tired but satisfied. Behind them, faintly visible in the sky, is the contrail of a V1 flying bomb, and beyond that, barely perceptible in the photograph, is a small black burst. The explosion of a 90mm shell at the exact point in space where the radar predicted the target would be. The Germans who launched that bomb never saw the radar. They never heard the calculations. They only knew that their weapon, their carefully engineered instrument of terror, had ceased to work. And they could not understand why. After the war, captured German scientists and engineers were brought to Allied research facilities and shown the SCR 584 system. Many of them were astonished. Some were skeptical, insisting that the specifications must be exaggerated, that the performance claims were propaganda. Others were silent, staring at the equipment with the expression of men who had been beaten by an opponent they had not known existed. One German radar engineer, interrogated by American intelligence officers in late 1945, was asked what he thought when he learned the Allies had been using microwave radar for fire control since 1944. He paused for a long moment, then said simply, "We thought you were bluffing." It was a common sentiment. The Germans had developed their own radar technology, had used it effectively for air defense and naval gunnery, but they had never integrated it to the degree the Allies had. Partly this was due to technical limitations. Partly it was due to institutional resistance. German military doctrine placed great emphasis on individual skill and leadership, and there was reluctance to trust machines with life and death decisions. But mostly it was because they had underestimated their enemy. They had believed the Allies were wealthy but unimaginative, powerful but bureaucratic, capable of mass production but not innovation. The SCR 584 proved them wrong on every count. The system itself was a marvel of engineering, but it was also a product of collaboration on a scale the Axis powers never achieved. The core technology was developed at MIT, but the components came from factories across the United States. The magnetrons, the heart of the microwave radar, were manufactured by Raytheon in Massachusetts. The analog computers were built by Bell Laboratories in New Jersey. The trucks and power generators came from assembly lines in Detroit. The antennas, the cables, the control panels, all were produced by different companies, coordinated by a supply chain that stretched across a continent. And then there was the human element. The radar operators were trained in weeks-long courses that combined physics, electronics, and practical troubleshooting. The gun crews had to learn to trust the machines, to fire at targets they could not see, to believe that the numbers on the dials were more reliable than their own eyes. It required a shift in mindset, a willingness to accept that warfare was no longer purely a test of human courage and skill. It was becoming a contest of systems, of information, of who could see farther and respond faster. The Germans, for all their technical prowess, never made that shift. They built individual weapons of extraordinary capability, the Me-262 jet fighter, the Type Victuin submarine, the V-2 rocket, but they never built the networks and systems that would have allowed those weapons to reach their full potential. They fought World War II with a World War I mindset, relying on heroism and tactical brilliance to overcome material disadvantage. The Allies fought with assembly lines and radar screens, and they won. By September 1944, the V-1 threat had been effectively neutralized. The launch sites in France were overrun by advancing Allied troops, and the remaining bombs were fired from modified Heinkel bombers over the North Sea, a far less effective delivery method. The SCR 584 batteries remained in place, vigilant, tracking the skies with their invisible beams. In the final months of the war, the technology was adapted for other uses. SCR 584 units were deployed to the Pacific, where they directed anti-aircraft fire against Japanese kamikaze attacks. They were used in the artillery role, providing precise targeting data for long-range guns bombarding enemy positions. After the war, the technology became the foundation for modern air traffic control, weather radar, and missile guidance systems. But in the summer of 1944, on the cliffs of southern England, the SCR 584 was a weapon, and it was a revelation. There is a passage in the post-war memoirs of a British anti-aircraft gunner who served in one of the first SCR 584 batteries. He wrote, "For weeks we had fired blind, hoping to hit something, anything. We heard the bombs overhead, heard them cut out, heard the explosions in the distance. We knew people were dying, and we were powerless to stop it. Then the Americans arrived with their radar, and everything changed. Suddenly, we could see, we could track, we could kill. It was like being given eyes after months of blindness. The bombs kept coming, but now they died. And we watched them die, one by one, on a green screen in a dark truck. It felt like cheating. It felt like the future." He was right. It was the future. The V-1 flying bomb was designed to terrorize. It was meant to be unstoppable, relentless, a symbol of German technological superiority. But it became something else entirely, a symbol of the limits of that superiority. No matter how advanced the weapon, no matter how clever the design, it could not overcome an enemy who could see it coming from 30 miles away and calculate its destruction with mathematical certainty. The Germans had built a weapon that removed the human element from attack. The Allies built a system that removed the human element from defense. And the system won. In the years after the war, as the Cold War dawned and missile technology advanced, the lessons of the V-1 campaign were not forgotten. The SCR 584 became the ancestor of the SAGE air defense system, the Aegis combat system, the Patriot missile battery. Every modern radar-guided weapon traces its lineage back to that green phosphorescent screen in a truck on the coast of England, watching a blip move across the sky and calculating where it would die. The Germans thought radar was a bluff. They thought it was a tool for detection, not destruction. They thought the Allies were fighting with numbers and luck. They were wrong. And in the cold mathematics of war, being wrong is fatal. August 28, 1944, 11:32 in the morning. The last V-1 flying bomb to be intercepted by SCR 584 radar over the English Channel exploded at an altitude of 4,000 feet, 6 miles offshore. The gun crew never saw it. The radar operator watched the blip disappear from the screen and marked it down in the log. One more target destroyed. In Germany, engineers were already working on the V-2 rocket, a weapon that would fly too high and too fast for any radar-directed gun to intercept. It was the next evolution, the next escalation. But by then, the war was already lost, and the V-2 campaign would be remembered not as a turning point, but as a final, desperate gesture. The SCR 584, by contrast, would be remembered as the moment when war became a science, when technology turned invisible, silent, and absolute, when the future stopped being something you could outrun because the future had already calculated exactly where you would be. The Germans had thought radar was a bluff. They learned too late that the only bluff was their own belief that human courage and engineering brilliance could overcome an enemy who had learned to see in the dark, to calculate death in milliseconds, and to kill with unnatural precision. The age of automated warfare had begun, and it had announced itself not with a roar, but with a green dot on a screen and the cold, quiet certainty of mathematics. Thank you for watching. If you enjoyed this historical deep dive, please like the video, subscribe to the channel, and tell us in the comments which historical figure we should cover next.